Hello and welcome back everyone into this fifth video where we're going to talk about introduction to robotics and we're going to go into loops. Now, we have already started our journey on controllers and we have understood that controllers are pretty much one of the most important thing which we're going to talk about. Now, apart from being one of the most important elements in robotics, they also play a very important role when you're designing a controller. So in this video, I'm going to talk about some of the approaches that we used while designing a controller and how you can also know about them. So without any further ado, let's get into it. Okay, so let's see what do we have when we talk about controllers at once. Okay, we start with loops. Okay, now loops are quite an important thing when we talk about programming in robotics or programming in general. In robotics, a loop refers to as a feedback loop that is used to adjust the robot's behavior in response to change in the environment or the task being performed. Now, previous video, we talked about what is a feedback loop. And in this video, we are going to talk about what exactly defines a loop. Now, for any loop to actually function, we need to have this understanding that the data is going to flow in a circular manner. It means that if the data is going from the sensors, it's going to go back to the actuators and so on and so forth. Of course, the controller is always involved, but this loop needs to be maintained in order to make sure that the software or the robot is working the way it's supposed to. And this makes it quite a responsible option to know when you are working with robots as well. Okay, so now that we understood that, let's see what do we have over here. Feedback loops are used to provide information to the robot about this behavior, which is then used to adjust the robot's motion and performance. Okay, so essentially speaking, what we're doing is we are sensing the information and we're continuously sending it back. The way or the reason why we are sending it back is to make sure that the robot knows its current situation all the time. Okay. What we're doing is we are continuously updating the information in the robot and telling him, okay, this is something which is going wrong. This is something which is going wrong. And the robot will continuously know that things are going wrong. So it will start to fix it up. And that's very important. Then we have types of feedback. Okay. Because feedbacks is quite an important thing. So we need to know what the types of feedbacks are. Okay. There are several types of feedback used in robotics, including position feedback, force feedback, and tactile feedback. Now, feedbacks are nothing but any sort of a physical input that you're giving to the robot to know its current situation. Let's start with the position feedback. Very, very important, actually. Very, very important. One of the most important one. For position feedback is used to provide information about the position and orientation of the robot end effector. Now, end effector, if you remember, is known as the gripper of a robotic arm. Okay. And position feedbacks gives us the position or the joint angles of the robot all the time. Okay. So why does it help? It helps to check if the robot has reached that position or not. Okay. If we don't have position feedback, chances of robot doing something wrong is very high. Okay. These sensors not only save a lot of time, but also save a lot of opportunity costs that could be there as well. So position sensors are a must, which are you can find every time in a robot. So that's kind of like a very mainstream thing these days. Then you have force sensors or force feedback sensors. It is used to provide information about the forces acting on the robot end effector. Let's say your robot is holding a bottle of water like this, okay? So the weight of the bottle is obviously going to be significantly high as compared to, if the robot is holding a phone like this. So depending upon what the object is holding, there is going to be a force feedback, and this force feedback is going to tell if the robot is gripping the right thing or not, okay? It's essentially a feedback which is used to understand, how much load is being kept on the robot, and it can help the robot to, estimate and make changes as it goes. Then we have tactile feedback. So tactile feedback is used to provide information about the robot's contact with the environment. Okay. What are we doing is we are actually like introducing tactility. Tactility means that, we are going to understand if it's holding something or if it's gripping something or if it's like, in a situation where it's going to, pick up something. All of these things are known as tactile feedbacks, and, tactile feedbacks helps the robot, understand how is the environment interacting with the robot and how it should work around the environment. And then you have control loop, again, like closed loop control systems, control loops with closed loop systems. Closed loop control system used to give feedback loops and to adjust the robot's behavior in response to changes in the environment or the task being performed. Now, closed loop, if you remember, we talked about this in the previous class as well, that, closed loop systems are nothing but systems which have a feedback which is always going in. Okay, so closed loop systems are quite a prominent field, of course. And for every task that the robot is doing, a closed system is always going to behave better as compared to an open loop one that we already know from the previous classes. Closed loop control systems are used to ensure that the robot's behavior is precise and consistent, which means that, whatever the robot is supposed to do, it's only doing those things, and it's not making a mess out of the system. And that's very important. Okay, and then we have closed loop control system use sensors to provide feedback. Of course, any sort of feedback that we are taking is going to be taken from the sensors. So once we have the data from sensors, then the robot makes an adjustment according to the sensor data, and then it performs, whatever it needs to perform. Now, we are in the domain of understanding PID, okay? So PID is one of the most favorite controller for anyone in the market when it comes to robotics, because PID controller takes care of a lot of things automatically when it comes to robotics. Okay, so PID basically means proportional integral derivative. We have all learned about all these mathematical terms in our 12th grade, 11th grade, and over here, a control system or a PID controller is a type of closed loop control system that is commonly used in robotics. Now you might be thinking, where are we even using PID controller? Let me tell you, there is absolutely no place on earth which is left without the use of PID controller. Even the GPS that you have on your phone has a PID controller to make sure that you get the perfect data or you get the perfect location of where you are. Okay, because a lot of time what happens is, like, if you're in a room or if you're inside a building, GPS signals are very weak. Okay, at that time, PID is the one who is responsible for estimating the accurate position of you and then telling where you are right now. So PID control uses feedback loops to adjust the robot's behavior based on three factors: proportional, integral, and derivative. Okay, the proportional factor adjusts the robot's behavior based on difference between the desired behavior and the actual behavior. Now, the good thing about PID is you can tell PID controller how you want the output to be, and PID will, there is obviously like self-tuning methods, but PID controller allows you to tune your control system or tune your system in such a way so that you can achieve the output that you're looking for. Very good approach when it comes to controller, because you are just telling the controller how you want the output to be, and the controller will ensure that it remains that way. The integral factor adjusts the robot's behavior based on the accumulated error over time. So, in PID, okay, a very simple way of understanding PID is that, it's going to take, input from the past, apply it on the present, and to predict the future. Okay, so it's essentially doing the same thing. It's going to take a lot of errors which the robot has done over the past time, and then it's going to try to learn those patterns, and it's going to try to avoid those patterns as well. So the derivative factor adjusts the robot's behavior based on the rate of change of the error. Okay, how much rate of the change of the error was happening. If you see what I'm trying to say is, like, all of these factors are applying to, and learning from the past and applying it to the present. And then you have a bonus. Then we move on to the derivative, which we are going to cover in the later part, but we move on to the importance of feedback. So why do we even need feedback on the first place? Okay, feedback is essential for robots because it allows for robots to adjust its behavior based on the changes in the environment or on the task being performed. So, anytime if there's a change in the behavior, because the robot has sensors to figure it out, and that's how it reacts to it. Feedback loop allows the robot to maintain, precision and consistency behavior, which is critical for many applications of robots such as manufacturing and surgery. Manufacturing, it's quite an important thing for any robot to know the feedback and to know what it's gripping. If it's gripping the wrong thing, let's say a robot is gripping a glass bottle instead of holding an egg, possibly it's going to slip, because holding an egg versus holding a glass bottle is very different. So the sensor need to adapt to the change, and they need to grip the bottle quite hard if they want to grip it. In conclusion, loops feedbacks are essential components of robots, allowing the robot not just to adjust its behavior in response to changes in an environment or the task being performed. Okay, so essentially speaking, we talked about control loops and feedbacks, which allow us to have the change and the dynamicity of any sort of new adaptation that happens on a system, and make that change possible for the robot. Okay, if we don't have these things, then chances of a robot not performing the way you want things to be performed is quite high, and that can also bring a lot of damage and break to the system as well. So that being said, this chapter gets concluded here. There are other types of feedback, of course, which include position feedback and force feedback and tactile that we already understood today. And for the controller, we understood PID controller, which is a common type of controller which is being used, and we discussed how that works as well. Feedback. Okay, then we came to the feedback where we talked about different applications of robots. Where we need feedback. And especially in the field of production, that's where we need the feedback the most. And that's it for today. I hope you had a lot of fun today. And I'll see you all in the next class. Till then, happy learning. Peace.